So today we are picking up from where we left last time, and then we get to finish creating a canister with a full CRUD functionality and see how we can go about canister upgrades in Motoko, that we can persist our data so that it won't be lost during updates and everything. So go ahead and share my screen. So we'll continue with the same project.
Yeah, I sent the code for the users that you...
Oh, you send the code?
Yeah.
Okay, thanks. So to those who are new to this, what we are doing here is we are creating this function to get a user. All right, yes, I think it's a good point to start on. We're creating this web our users map, a try map. Then we have the function to add a user, and then we're on this function to get a user. So we are using the result type, which allows us to handle OK and error results. Okay, like in your function, you are not always expecting like a single value. Something might go wrong. A value might not exist, or something else. You might have multiple scenarios. So this result type will help you to take care of all those cases, and you can have some comprehensive error messages in your code, in your project, right? So that's where this result comes to handy. So here what we are doing is we are getting a user. We want to get a user by an ID, by a specified ID, but the user may or may not exist. So we need the result type to handle those cases. To handle those cases. So in the case of when we find the user, in the case of, okay, so we use a switch statement with the input of what we are trying to find. So we're doing users.get, and then if we get the user value, for the case where the user value exists, we do what? We return an OK with we return an OK. We return an OK wrapping around the user value, and then for the case of where we have no, right, where there's nothing, we return the error user not found, right, like this. So okay, let me just format this code better so that you can clearly see what's happening. These shortcuts kind of confuse sometimes, especially when you are learning. Okay. Cool. So we pass the value we want to switch on. Here we are using user.get, and then if the user exists, we return an OK. If the user doesn't exist, we return an error. And let's move on to, we want to what? To get all users. So it will be a public shared. It will be, okay, so there's this keyword which we have to introduce now, shared, right? So it's important when you know that some other canisters will have to call functions in your canister here. So if you don't put shared, that won't be possible. But if you know for some reason some other canisters we need to do some inter-canister calling, you need to communicate either canisters in your own project or canister in other projects. You have to put the keyword share. So I think if you don't specifically have a reason not to, you should like just always put public shared on your functions, so that you won't have some problems later on in places where you want to do inter-canister calling. Okay, so let's do a function to get all users. So it's a query function because we are not updating the state. So yeah, get all users, get users. Here we want an array. So an array is specified like this. So if you're familiar with JavaScript, TypeScript, you usually do it like this, but in Motogo it's different. You put it inside and not outside. The user, right? And what you want to return, so are the values, are the array, is the array of user values, right? So how you do that is using what data structure was in iterator. So you import it by just typing its name, iter dot, and then you call a function from that iter called to array, and then you call it on user values. So this one will convert the values in this map, in the user's map, to an array, and then you will have an array. So you can have it in many ways. In this case, we just wanted the values, right? But in some cases, you might want the whole thing, the key value pairs, because as you can see here, we are storing the user as key value pairs. We have the user and the key, right? So in your implementation, you might want to have all that data at once. So how you would go about it is in here, it won't just be a user, it will be what's happening? It will be text, comma, user. So you're getting the key value here. And then here now you are not saying values, you are not saying entries, because we are getting the whole thing. And yeah, it will work like that. But for our case, we don't want this, we just want the user. So we will just go ahead and do it like this. Yeah, here there are no error cases, so you don't need to do like a result of some sort. And then to update, public shared function update. Update user. So yeah, I didn't put the query keyword because it's an update function, right? So I will just add the args as the user type, because we have a new object. We have an updated user object we want to put in our map, right? So it's an asynchronous function, and then do we want to return anything? Usually in like update, you usually don't want to return anything, but you can return something if you want. Like you want to see the value you just updated, you can just return it. So really, the update function is like identical as the add user function. It might differ depending with your use case, but like if it's a simple thing like this, the update function will just work the same as the add function, because we just use the put function. So it won't create duplicates. What it will just do, it will just override the value that is on the given key. So that's what it does. So you don't get to have duplicates in the map by default, right? So what we just do is users.put just like that. So the user will be updated. So it's functionally working the same way. I think it's just good to have it so that you won't confuse yourself in the code. Like here, I'm now updating. Here, I am adding. So to delete the user, yeah, this function is correct. Okay. So it's giving an error here because this remove function from the map, from the try map, it looks for a value and then deletes it. So it can return a no value, right? So in some cases, you might want that, like you want to know if the value you are deleting existed in this here. So let's say you want to do some type of, what is it? Create, I don't know, maybe create or, no, this doesn't apply here. It doesn't apply here. But anyway, you might have a case where you need to find out first if the value exists, and then you know something. So it returns a now. So you can not use it. You can use the delete function. This one, it won't care if the value exists or not. It will just delete and keep quiet. And if it finds it or it doesn't find it, it doesn't care. So you can use this delete function. Okay, so there is another type we might want to discuss as well, which you might find yourself as you try to build some complex canisters. You might need to handle some various independent cases in your code. So it brings us to this type called variance. If you're familiar with TypeScript or any typed language, you should be aware of this. So let's say we want to have some form of access control in our project, right? So let's have, okay, let's first have a type. Access level, right? And then we want it to be a variant. All right. So how you specify a variant is with the hash. You specify a variant with a hash like this. So either it's the owner, you want to check if the user is an owner, or an admin, or what, or just a normal user. What's that name? Yeah. Maybe you just want to have these 3 cases, right? So a user can be one of these. Like if your access control is in such a way that a user can only be one of these and not be like an owner at the same time as an admin. So this is how you handle the variant. Then here, and at the same time, like this variant type can also be, you have another value of its own. Let's say an owner could have another type, let's say owner type. Let's say owner, right? And then you can go ahead and specify the type of owner, something like this. So this also works. So it just depends with your use case. It's as flexible as this. But in our case, we don't want to associate our variants with any extra types. Just want to use them just like this, and they will work like that. So now let's just have here access level, and then put the type access level. So, and then how you would handle your variants is usually just with switch statements and yeah, and some result type, just that. So that's another case for use statement. Using Motoko, you will find yourself wanting to use the use statement quite a bit. So let's call the function, what can you say? Public shared, let's have it as a query function. Let's say the user access level. Yeah, and then we pass in the ID. This is wrong. Okay, so we just want to get some text for now. We just want to get some text that tells us what the access level of the user is, right? So let's do switch statement. We want to get a user with a given ID. And then for the case of no, yeah, we will get an error. Yeah, we'll get a text telling us, okay, let's have it as a result. That makes more sense. As a result, that is giving us texts in both ways. So if it's an error, we're getting a text. If it's an error, we're getting a text. We're getting a text telling us there was an error, the user is not found. Then if it's okay, we also get some text. telling us everything went okay, and this is the user's access level. Okay, so we switch and then we find the user, and now we want to switch. We want to do another switch statement on the user. Exactly. Yeah, Copilot saved me. Okay, what's this error? Switch statement. This one is not closed. Okay. So we are switching on user access level, and then for the case of owner, let's make it more clear. User is owner. In case of admin, user is admin. User is a normal user. It's a normal user, right? Just like that. So let's test it out. TFX deploy backend, it will give me an error. TFX start in background. Let me run it in the background. Then let me deploy backend. So I can test it out. User ID. Let's just say 1. Access level. Admin. Name. Created it. Mail. So the user is added. Let's get the user. Let's get all users. Yeah. You see, it's a vec. That's an array. So we only have 1. Then let's get user access value. So our ID is 1. User is an admin. So yeah, it's working as it should. But still one thing, this code is still not, like the state is still not stable. If I do some little change, let's say, let me just comment out this code and deploy again. And then I call I get user 1, user not found, but we just added the user. So it's because still our variable is not stable. There is no upgrade system happening. Our state is not being persisted during upgrades. So on a maps like this, like on these data structures, on these class-based data structures like try map, hash map, buffers, you can't just use the keyword stable and call it a day. It won't work. They are not stable. these data structures. So there is a way designed for Motoko canisters for persisting the data across upgrades, right? So we know that there are some structures that are stable, like an array or a list or whatever. So let's create a stable variable. Let's call it user entries, users entries. So it will be an array of text user. It will be an array of the key value pairs of users, right? And it's stable. What's wrong here? Okay. Stable variable. And then there are some functions, some system functions that are available that will help in the process of upgrades. So what it does, it before an upgrade, the data is serialized, it's stored in the stable storage, and then after the upgrade, it's brought back. So they are called the pre-upgrade and the post-upgrade functions. So you find them like system function pre-upgrade. Yeah, smart, but not really. Yeah. So what we are doing is just before the upgrade, we are just taking the values in the map and putting them in this table. In this table variable, right? And then we have a system post upgrade function. Not cool here. So it's from entries. User entries. Dot values. Cool. Right. Yeah. So that's the cycle you just need to do. So before the pre-upgrade, we assign the users to this stable variable, and then after the upgrade, we return them back to the map. And then we use them in our, that way our data won't be lost. So let's run it again. Now let's say the user ID one this time. Whatever. Okay, our user is there. Let's get a user. Yeah. Now let's do some changes in the upgrade. Right. So we just upgraded our current, so it changes. Let's try again. Let's get user. one. Yeah, the user is still there. So now you have stable data persistence in your canister. And yeah, you can continue scaling it however you want. And just a small teaser, something we will touch in detail as well. So a actor, this canister here can also be a class. It can also be a class. So what can I say? The class is this how you define it. The class no, like this. Mm, okay, I'm confusing the correct index, but anyway, you can set an actor as a class. We'll get into this. What this means is, as you can imagine, as you are trying to build a scalable application with multiple canisters, you, and you know, like at some point this canister is going to get full, right? So you can have your actor as a class. So if you are familiar with classes creates objects, right? So what this means is if you set this as a class, this actor as a class, you can just maybe need to have one canister, maybe an indexing canister that will be managing. And then, so what it means is you'll be dynamically creating canisters. So that way you'd like to scale your canisters infinitely, like whenever it's full, you can just call a function. It will need to happen programmatically, and another canister with the same implementation is created. Yeah, just a teaser, something to know. We will do it and demonstrate it in the few coming lectures. So that's it for the demos today. I would like to introduce you to some homeworks which you can start working on. And then I think by the end of the week, you guys should be able to create a unique Motoko canister of your own and submit it, like the one that is unique from what we are doing here. And then you submit it. And then when we go on to next from third weekend, fourth week, we'll be touching on other aspects that are not really creating a canister, but advanced aspects which are even language independent. Like it's just implementation you can have in Motoko, in Rust and wherever. So it's good you push these homeworks. Then maybe by the end of week or so, how you're going, you try to create a unique canister of your own, based on the experience you have gained from the homeworks and the mentorship sessions we'll be doing. So I will show you the homeworks. So these are the homeworks that are also attached in the schedule document. All right, you will find the homeworks there. The homework one. So it's like this. Then you come, if you have good time, just for some refresher, for some concepts, go through this, reading this information here. And then you click on project. You're asked to create a calculator application, right? So follow the description and instructions. And these are the interfaces. So you don't, like, this is not how you write the Motoko code, the canister, right? This is like an interface description in a way. Like when you're describing a function, you describe it like this, like for the internet computer to kind of understand it, right? But that's not how exactly you write your code. So the way, so this is just helping you to show you how exactly the function would be like. What's expected? It's a function, it's a shared function accepting a float, and then it's returning a float, right? So I think if you open main.mo exactly, here you can actually see the template, the boilerplate code that's already there for you. So there's nothing much. Yeah, there is, but I mean, some good part of the code has already been done for you. Some functions definition, so you just need to fill up these functions and yeah, test them out. Test them out. Usually, the best you need to do it is on the playground. On the playground. So if you're still having troubles like setting up the local environment, these homeworks you can get by just using the playground. So you just come and grab this code and have it. Just come and grab this code and have it either in your VS Code. It's screaming at me. There's a lot of unfinished stuff. Right? Then you start writing your magic in here. Yeah, following these instructions, define a mutable variable and follow this. And then once you are done, and then you test it out, you deploy it locally, or you deploy it on the playground and test it out. And then for submissions, there's a few updates we are fixing on the website for submission, but we will let you know tomorrow when you can go ahead and continue to submit. But the submission website is what's the is it? So you can see it's also an application running on the internet computer. It's a React. This whole website is a React application hosted on the internet computer with a Motoko backend as well. You can actually take it out on Musan's Web3 and see how it's working. It's a simple implementation, really, that is the one that is actually working. Then you log in. Okay, so we are saying, so this is the page where you will be submitting. But we're saying, like, for now, don't submit it yet. We'll let you know just tomorrow when you'll be able to submit. So what you do for submissions is you have your canister ID after submitting, after deploying, and for submission, this canister have to be deployed on the playground. You can deploy on the actual playground front end, Motoko playground on the actual Motoko playground, like this one. And then after deploying, you grab the canister ID that's deployed here, and then you come here and you paste it, and then you select which homework. Is it homework 1, 2, or which one? And then you select homework 1, and then you submit, right? I'm saying it have to be deployed on the playground because it have to be a live canister for the verifier. The verifier that will check if your code is running correctly. It's live. It's on a live canister, right? So the canister have to be live as well. So once you deploy it on the playground, here you come and paste, then you submit. Or if you want, if your local environment is working fine, you don't have any problem, you can deploy locally here. Like you can deploy from a computer to the playground. You just need to pass in the playground, like TFX deploy background, backend, and then playground. So now it's deploying to the playground. For me, if I want to test, this is usually how I go about it. I rarely write the code on the playground itself. So it's being deployed to the same place, but I'm doing it from my command line. So this canister is actually live, but for 20 minutes, it's deployed on the same environment as where you deploy if you deploy from here, right? The only difference is I did from a command line with the flag playground. That's all. So again, once I deployed here, I just grab the canister ID, this one at the end. This one at the end. So you might be wondering, here you can also get your canister IDs, but for the playground case, it's not updating them. So the best way, you just get it from here. Or once you open the candid UI, you can also see your canister ID from here, just in case you are being confused. Because I mean, there's this canister ID, there's this one, just in case you're confused which is which. If you open the candid UI, it will be just this one, right? And then you come, you paste it, you select which homework number it is, then you submit. And then if it's verified, it will tick it like this. Yeah, so this project. So in my case, I already finished homework 1, so no worries. Okay, let me try homework 2. Yeah, it's giving me this error because I mean this canister is not even deployed somewhere. It's like a local canister URL. So it's giving me this error. So you'll be seeing these errors, but once your code is running correctly and you have followed the instructions well in the homework, and if you have followed the instructions in the homework, you should verify and you see the progress that is completed. So yeah, check the schedule document, play around with the homeworks, and then tomorrow we will let you know when you can go ahead and do some submissions and see if your code is working. In most cases, like you can test it out and it will work, but the verifier may reject it simply because maybe you used the wrong function's name, because this one will be looking for like this exact function name or whatever. So again, don't be disappointed if the verifier is like rejecting your code while it's working smoothly. But you just need to check if the functions are names and the expected return types are correct, the expected input types are correct, and then you should see your progress here and the verification should be successful. So that's it for today, guys. Can take questions at this point. Looks like everything was okay. Hi, Afikile. Did you manage to get it running?
Hello. No, I haven't made any changes. I'm writing this week.
Okay. Okay, it's fine. So as for the homeworks, if you want to start playing around with them already, you can get the code, you have it saved locally on your computer, and then you can test it on the playground. Yeah, but yeah. Okay. So that's cool, guys. Have a good night. Okay, there's a question. How can I link 2 types? Let's say the student details and courses they are taking. Okay. Let me share my screen. How can you link 2 types? Let's say students and the courses they are taking. There's a couple of ways you can go about it. So let's say you have courses, right? Usually courses, there will be like multiple courses. So you might want to have a stable variable for the courses, right? So let's create a type for courses. Type course. Okay, we have the course, and then let's have courses. Courses, and then we have we'll be using courses with like with a unique ID. Maybe it will be a UUID or something. Okay, so now we have a courses variable. Let's have it on its own. Right. So now you want to link, you want to have some relationship between a user and the courses they are doing. So what you can do is, so the user, in your case, are the students. You can have another variable that is connecting the two. So you can have it as variable user courses. User courses. So what you can do is, so you're saying a user can have multiple courses. A user can have multiple courses. So you can have the course, the multiple courses as a list. Okay, there we go. Like this. So what's happening here is we're saying a user can have multiple courses, right? So we have, so where we have this stable variable, like this table for users with their associated courses. So what you would do is when a user decides to take a course, what you just do is pass in the ID for the user. So as the code starts to get like this, you will need to have some clear definitions of what these texts are. So you can just have a type of like user ID, which will be in text, right? Type user ID equals to text. Okay, yeah. And then here we can put user ID in the instances. In these instances of text, we can put user ID. This is for code readability, just so that you can know exactly what these keys are, right? So you don't confuse yourself. And here it might be like course ID. Type course ID. And then here you know that it's a course ID. Course ID, right? So we're having a list, a user ID associated with a list of courses IDs. So what you will then be doing is to have some CRUD functionality where when you are giving a user a course, you query the user ID and then you add the course to their list of courses. And then or even another bigger way is to have the course itself. The course itself. That's another alternative. You can either put the course ID if you don't want this array to grow quickly, because the course ID will have less space, it's just a text, or the actual course itself to have a list of the user with their associated course list. So you have CRUD functionality for courses, and then you have CRUD functionality for user courses, where you'll be adding a user to a course, where you'll be adding a course to a user or removing a course from a user. So this is how you would go about it. Okay. Cool. Yeah, so our time have ran out, guys. We'll catch up tomorrow. The questions, you can pop them up in the Telegram group, and we'll continue there. So thank you, guys. Let's catch up tomorrow. Have a good
Thank
night.
you. Appreciate it.
Sure.